Good morning, students. I am going to start the class and you listen very carefully. If you have any doubt, you can write in the chat box. I am going to continue the class and listen it here. If you have the doubt, you write in the chat box. Listen it here. First, we are going to start the nuclei chapter. Okay. In the nuclei chapter, what we are going to discuss, and this is the important chapter that I am going to explain. You listen very carefully. Just it will complete within 2 or 3 lectures. It is a small chapter, so much amount of syllabus is reduced in this. And you listen very carefully. Now, listen at here. I am going to start the class, Aditi. Right. What is the nuclei and what we are going to do? Any element can be expressed like this. For example, any element if you are taking, the element can be expressed like this. An element can be represented by an element can be represented like this, like x z a we can write, or otherwise we can also write z x a. This is an element. Okay, you see here we wrote here something z x a. This is indicates one element. In that, what is z and what is x, what is a? Okay, what is x in this, that we are going to discuss. And for the purpose, you see here, what is z in this? Z means atomic number. Z means atomic number. What is an atomic number? Atomic number means it is the number of protons. Atomic number means number of protons. Okay. X is what actually? First of all, we have to discuss about the X. X is the some element. X is some element. Okay, either hydrogen, helium, lithium, like that. That element can be indicated with X, and Z is an atomic number. Atomic number indicates the number of protons. Students, my voice and writing is clear now? Okay. X is the element, and A is the mass number. A is the mass number. What is A? A is the mass number. What is mass number actually? What it explains? Mass number is the sum of number of protons and number of neutrons. Mass number is nothing but sum of number of number of protons, number of protons and neutrons, right? And neutrons. This is nothing but we can write A is equal to A is the sum of Z. Z is the atomic number. It is the number of protons, and number of neutrons is the n. We can write A is equal to Z plus n. We can write sum of what? Number of protons and number of neutrons. Z is the number of protons and n is the number of neutrons. What is n in this? N is the number of neutrons. Number of neutrons. And now here a minus z, what it will gives? Okay, z is the number of protons, a is the mass number, that is the sum of number of protons and neutrons. And if you find out the a minus z, okay, from above equation, if you find out the a minus z, it will gives the number of neutrons. Number of neutrons. Is it clear, Aditi? Number of neutrons. Okay, and the next one is the, I'm going to explain one thing, that generally element can be expressed like this and what terms it can be indicated. And now classification of elements I am going to explain. Classification of elements. the classification of nuclei. How we can classify the nuclei? Then for the purpose, we can write like this. The elements can be classified into many types. Okay, in that we will discuss some types. The first one is the isotopes. Okay, isotopes, isobars, isotones, isomers. Okay, there are some types, four types are there. And now first I am going to explain the isotope. Isotope are what? These are the some nuclei. Okay, the nuclei of elements which have the same mass number and different, sorry, same number of protons and same atomic number, but the different mass numbers. Okay, are you understanding? If you have any doubt, write in the chat box. You write it here very carefully. You have to listen every point. If you have any doubt, if you have any query, you can write in the chat box and listen very carefully the important topics we are going to discuss. Right, what is isotope? The certain elements are classified into isotopes, isobars, isotones. Okay, the nuclei. Okay, the elements, the nuclei of elements which have same atomic number, same atomic number, but different mass numbers, but different mass numbers. The nuclei, the elements. Okay, the nuclei of elements which have same atomic number but different mass numbers are called as isotopes. This is about isotopes. Next one is isotopes example I am going to give. For the purpose, you see here 1H1, okay, 1H2 and 1H3. These are the, okay, they have the same atomic number. You see in this, what is the condition? Z should be same. Okay, Z should be same, but the mass number may be varies. Mass number is different. Then such elements, these are all the called as hydrogen isotopes. Okay, 1H1 is called as, what is 1H1? 1H1 we can call as, it is the hydrogen. Okay, just it is simply one proton. Okay, here 1 means this one indicates the number of protons. Okay, and 1 a minus z, if you will do a minus z, you will do means you will get the number of neutrons. You see here 1 minus 1, number of neutrons is 0, right? That means this is just like hydrogen, it consists uh, one proton and along with that one electron. Number of electrons is automatically equal to the number of protons, you know this one, right? Next 1H2. 1H2 is what is the name of this 1H2? Deuterium, na? Right, deuterium. 1H2 is called as a deuterium. And what is 1H3? 1H3 is called as the tritium, right? It is called as tritium. Is it clear, students? Any doubt you have? Okay, and next you take the screenshot, then I will continue. Next, isotopes completed. Next, I am going to explain the isotones. No, 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 isobars I will explain. Isotopes, after isotopes, I will explain the isobars. Okay, if you want, I will explain here. I will give all types of classification at here. Okay, you hear first one is the isotopes completed, and the next one I am going to explain, that is second one. The second one is the isobars. Isobars. Isobars means what? Okay, isobars means these are the nuclei of elements. The nuclei of elements. These are the some elements. Okay, the nuclei of elements which have same mass number, which have same mass number, but different. The nuclei of elements which have same mass number but different atomic number. Different atomic number. These are called as isobars. Okay, are called as isobars. Example for the isobars. In isobars, what is same? What is same? Mass number is same. Mass number is denoted with A. A is the same. A is the same. A is constant. But what is changing it here? Atomic number is changing. Z is changing it here. Okay. Z changes. Z is different. Then I will give the example for this. The example is that 1H3, right? You know this one. Isobars means mass number should be same. Okay, I will take that 1H3, right? And the other one is the 2 helium 3. Okay, this is an hydrogen isotope, this is the helium isotope, and these two are having the same mass number. You see 3 3, mass number is same. In the element, generally element is indicated with that is A. In that A is the same for these two elements, hydrogen and helium, and these are called as isobars. These are called as isobars. Now, next one is the third one. Isobars means they have the same mass number, different atomic number. You see. Next one is the isotones. Isotones means what? Isotones. Isotones are the nuclei of elements. The nuclei of elements have the nuclei of elements which have same number of neutrons. Same number of neutrons, but the different mass number and but different atomic number and mass number. Right, the chart. Are you doing anything right here in the chart box? For me, anything is not appearing. Right, something. Different, the nuclei of elements have the same number of neutrons but different mass numbers, and atomic numbers are called as isotones. This is about isotones. In this you see here, example I will give for the isotones. They have the same number of neutrons. Same number of neutrons means what? Which one gives the number of neutrons? A minus Z gives the number of neutrons. A minus Z should be constant, it should be same. That is the number of neutrons, right? Number of neutrons is A minus Z, that should be remains constant. And the next one is the example for the isotones. In this, number of neutrons should be same. Then for that you can take like this. 1H2 you take, and the second one is the 2 helium 3 you take. These two are the examples for the isotones. They have the same number of neutrons. You see here, hydrogen has one atomic number and helium has two atomic number. That is different. Mass number, hydrogen has 2 and helium has 3. That are the different, means they are having a different atomic number and different mass number, but the m and z is same. You see, m and z means what? Generally this 2 is the a and 1 is the z. 2 minus 1 1, 3 minus 2 1. That means in this hydrogen, in this helium, they have the same number of neutrons. That's why these two are called as the isotones, right? And the next one is the fourth one, that is the isomers. What are the isomers? Isomers means these are the some nuclei of elements. The nuclei of elements, the nuclei of elements which have which have same atomic number, same atomic number and same mass number, but different radioactive properties. Radioactive properties. Such elements are called as what? Isomers. What are the example for the isomers? In this, what happening? Z is constant. Okay, in this, what happening? Same atomic number. Means Z should be constant. Same mass number. A should be constant, but the different properties. Okay, what is the different at here? Different properties. Different properties. That means one is in the ground state and other one is in excited state. That means different properties they have. Okay, and for this example is, I am going to give the example for these elements. Isomers element is the bromium. We will take example for this is the bromium. Okay, you take here 35. Bromium mass atomic number is 35. Mass number is, we can take it as 80. Okay, this is in, for example, this is in the ground state. Okay, ground state. And another one more element you take 35 bromium 80, but just giving the star market here. That means it is in the metastable state. Okay, it is in the excited state. These are having the same atomic number 35 35, same mass number, right? 80 80, but they are in different state. Okay, right? These are the example. Are you getting, students? I think it is not appearing na, 35 bromium in the metastable state, right? Because of my photo, right? Photo का पीछे में ही चला गया, right? Now you see here the nuclei of elements which have the same atomic number and same mass number but different radioactive properties are called as what? Are called as isomers. Isomers. Now we can, I will move this to left side, then you will get that one. Okay, and listen very carefully. If you have any doubt, you can ask me. Okay, I am moving to this side. Right, you take a screenshot now, and that is appears. Okay, And you see here isomers. Isomers are what? Bromium, bromium. But one is in the ground state and other one is in the excited state. These are called as isomers. And next, I am going to continue. Next, I am going to explain. Once I will revise these all things. Okay. Okay. Easily you can remember these all things. Okay. Isotones note I will give. Isotopes. Isotopes means what? Protons should be same. Isotopes means they should have the same number of protons. In this P is there same number of protons. Okay, you remember it. The protons are same. Protons, number of protons same. Number of protons same. Number of protons is what? Z. Z constant. Okay. Isobars. Isobars. Okay, bar means just for certain element. If you take this top one is a bar. You write generally bar like this. Bar is at the top. You remember A is the same here. A is constant. Isobars means A is constant. Mass number should be constant. Next one is the what? Isotones. Isotones means what? It will be constant. Isotones in the name only it is there. It is very easy to remember the definition. Okay, and that is isotones means tone n will be constant. N means number of neutrons will be constant. Number of neutrons will be same. Okay, and isomers are the elements which have the same atomic number and same mass number. A constant and Z constant but different properties. Different properties. And this is simplified. Okay, easy to remember. Isotopes means atomic number constant, protons constant. Isobars means mass number constant. Isotones means number of neutrons constant. Where n is what? N is the number of what? Number of neutrons, right? Okay, that will be remains constant. And the next isomers means a mass number and atomic number both are constant, but they have the different properties. This is the revision, very simple. Isotopes, how we can define the nuclei of elements which have the same atomic number, Z is same, okay, but different mass number. And isobars means mass number is constant and different atomic number. Okay, for a certain element what it will consist? It consists atomic number, mass number, and A minus Z is the number of neutrons, right? In some elements Z constant means isotopes, A constant means isotones, A minus Z constant means Z constant means isotopes, A constant means isobars, and A minus Z constant means isotones. Different properties both are constant means isomers. Okay, students, is it clear? Okay, next we will go for the composition of the nucleus. In the nucleus what it will be there? Composition of nucleus. Can you tell the nucleus is made up of what? What it consists inside the nucleus? Can you tell anyone? Write in the chat box. In the nucleus what are there? The nucleus consists what? Write in the chat box. Write in the chat box, students. Nucleus consists what? Okay, every atom consists nucleus at the center according to Rutherford alpha scattering. Rutherford alpha scattering, we discussed that the nucleus is the very small part at the center of the atom. Nucleus consists what? What it consists? Nucleus consists of positive charged particles. Okay, what they are? Neutrons. Positive charged positive charged protons, and one more is what? Neutral charged. Right? Neutral charge what? Neutral charged neutrons. Right? Means they are not have any charge. Okay, this is about the composition of the nucleus. And is it clear, students? Write in the chat box. I am not getting any messages from you. Do it fast. Response. Next, let us go for continuation. Take the screenshot and note. Right. You listen very carefully. If you have doubt, you can write in the chat box. Clear na till now? No doubt na? Right, very good. And now the thing is that we are going to discuss about the AMU. AMU is what? AMU is the atomic mass unit. AMU is the atomic mass unit. What is atomic mass unit? Atomic mass unit is denoted with the U generally. Okay, it is a U. What is atomic mass unit or what is AMU? What is the definition of this? AMU is the actually atom has a small particles, okay, and atom mass atomic particles are the nucleus particles, neutrons, okay, atom mass, nucleus mass, atom and nucleus, protons, neutrons, okay, and having the less mass, right, have very small mass, right. Now that's they have the small mass, proton, neutron, electron have the very small mass, and that mass can be measured with some smallest unit, not in kgs. The atom not have the kg mass, proton not have the kg mass, it was very less mass it has. If you measure in the kgs, you should write like this: the mass of the proton is the 0.000000000, like that you have to write some 20 zeros, then after that something you have to write, right. That means very less you will get. That's why we have to use another unit for to measure the mass of smallest particles, okay, which are present inside the atom, okay. Atomic particles have the very less mass, and they can be measured with they can measure by using small unit, okay. The small unit is AMU, small unit called as AMU. AMU means atomic mass unit. Then what is one AMU or one U is equal? It is the 1/12 of mass of carbon isotope. Mass of carbon isotope. Okay, right. This is the one AMU. One AMU is equal to 1/12 of mass of carbon isotope. What is the mass of carbon isotope? That we have to find out. You know that according to previous theory, right, okay, we know that 1 mole of carbon, 1 mole of any substance has Avogadro number of molecules or atoms, right. 1 mole of carbon if you will take, then 1 mole of carbon has Avogadro number of carbon atoms. That means 6.023 into 10 to the power of 23 carbon atoms it has. 1 mole mass is 12 gram, for the mass number is 12, that's why. Then that means 12 gram of carbon, okay, 12 gram of carbon contains how many atoms? 12 gram of carbon contains Avogadro number of atoms, right? Avogadro number means how much? 6.023 into 23 to the power of 23 carbon atoms. Okay, 12 gram of carbon contains 6.023 into the power of 23 carbon atoms. Now let us see. Right. Then what we are telling it here, 6.023 into 10 to the power of 23. This is the Avogadro number. This many atoms combinedly, how much mass they are giving? Right. This many carbon atoms giving the 12 gram mass, right? Then one carbon atom, how many? One carbon atom mass, how much it will be there? That we have to find out. Okay. You see here 6.023 into 10 to the power of 23 carbon atoms giving how much mass? 12 gram mass. 12 grams. Then one carbon atom I want. One carbon atom, how much mass it has? That we can find out in the grams. Just it was very simple. Oh, for the two chocolates, 10 rupees. For the five chocolates, how many rupees? To find this, we have to do like this. We have to multiply in the class 1 into 12, 1 into 12 by we have to divide this. And this is the procedure in the mathematics, okay? 6.023 into 10 to the power of 23. Now, this is the mass of what? One carbon atom. Okay, right in the grams. We got one mass, one carbon atom mass. I want one AMU. What is one AMU? Can you tell what is one AMU? One AMU is the one U that is equal to one atomic mass unit. Just like a kg is the unit of the mass. Okay, and gram is the unit of the mass. Like that, AMU is also unit of the mass. That is the a smallest unit of the mass. It is equal to 1 by 12 of mass of carbon atom. Here we got the mass of carbon atom, mass of one carbon atom. Is it right? Mass of one carbon atom, how much you got? Can you tell it is how much you got? 1 AMU is equal to 1 by 12 from here. Mass of carbon isotope. Mass of carbon isotope you got here 12 by, can you tell? 6.023 into 10 to the power of 23 grams we are getting. Okay, right, very good. Now we have to simplify it. Now, how to simplify it? 1 AMU is equal to, that is simply 1 U also we can write if you want, right? In some books we can, they will write only 1 U like this. We will also write 1 U. This 12 gets cancelled. What's remaining with here? 10 to the power 23 taken to numerator, 10 to the power of minus 23 by 6.023 grams we are getting. And we can simplify some more at here. Then for that I will do like this. This can be multiplied with 10 and divided with 10. Then we can add 10 into 10 to the power of minus 24 gram by 6.023 we can write. And here one thing we do, that 10 by 6.023 is what? 10 by 6.023 we will get as 1.66. Okay, this 10 into 10 to the power of minus 24 again gives 10 to the power of minus 23, and 10 by 6.023 gives 1.66 into 10 to the power of minus 24 grams. Have you got? One atomic mass unit is equal to 1.66 into 10 to the power of minus 24 grams. If you want to write this in kgs, if you want to write this in kgs, you convert grams into kgs. Can anyone tell 1 gram equal to how many kgs? 1 gram equal to how many kgs? Everybody, you should write roll numbers in the attendance box. 1 gram equal to how many kgs? 1 atomic mass unit equal to how many kgs? That you can convert and you can tell. Students, can you convert 1 gram into kgs? And then by that you can tell 1 AMU equal to how many kgs? AMU is what actually? AMU is the smallest unit of the mass. Smallest unit of the mass. Is it clear, students? Write in the chat box. Are you giving any sentences? Anything you are writing in the chat box? I am not getting any messages. Oh, I am getting. You are writing now? Latika Pradhan, clear. Puneet Kondayat. Yes, sir, clear. Very good, very good. Twinkle. Till now, I am not got the message. Just now, I am seeing the messages. Right. Aditi converting the grams into kgs. Right. Aditi, Sunita, Sushmita gave the correct answer. Right. 1 by 1000 kg. Then now you can write that 1 gram is equal 1 AMU equal to 1 AMU is equal to how many kgs? That you tell me. 1 AMU equal to how many kgs? 1 AMU equal to how many kgs? 1 AMU equal to how many kgs? Right. Write in the chat box. How is my photo? Is it appearing clearly? Right. I added the photo first time. Right. In the class 12. Right. Ah. Okay, students. Now I am asking one question that 1 AMU is equal to how many kgs? Can you convert that one? 1 U. 1 AMU is nothing but 1 U. Right, students? 1 AMU is nothing but 1 U. Atomic mass unit is the 1 U. 1 U equal to in kgs, you can tell me. 1.66 into. Very good answer. But lately, you are very late. Why you are answering very lately? 1.66 into 10 to the power of minus 27 kg. Right? Okay. Respond immediately. Now, the next topic is I'm going to explain uh, size of the nucleus. How we can find out the size of nucleus, right? You listen very carefully. Size of nucleus is what? Size of the nucleus is the, how we can find out the size of the nucleus? What the nucleus consists? Nucleus consists of protons and neutrons. The number of protons and neutrons is called as the mass number. Right? Then, for example, this is the nucleus, and if it has a more particles, protons and neutrons, then its size will be more. The size depends upon the size is nothing but either volume or the radius we can find out. Radius of the nucleus, right? Size of the nucleus, I want. Size of the nucleus means volume of the nucleus. If in the nucleus more nucleons are there, nucleons means what? Protons and neutrons collectively called as nucleons. Okay, protons and neutrons collectively called as nucleus. Okay, and size of the nucleus is what? Protons and neutrons collectively called as what? Collectively called as nucleons. What we call them? Nucleons we can call. And then I want the size of the nucleus. What is size of the nucleus actually? The size of the nucleus is nothing but we can find like this. Volume of the nucleus only size of the nucleus. Okay, remember it. Volume of the nucleus is what? You see here. This is a nucleus. Nucleus is in the spherical shape. Okay, like sphere. Nucleus is just like sphere. This is the nucleus. Let us consider. This nucleus has some radius capital R, and the nucleus has the nucleons. The number of nucleons is equal to A, right? A is what here? A is the mass number. Mass number is nothing but we can write like this. Mass number is the number of protons and neutrons collectively. Number of protons plus number of neutrons is nothing but number of nucleons, right? Number of nucleons. Number of nucleons. Now let us see here. One thing we have to do, that the volume of the nucleus, volume of nucleus is directly proportional to the volume of nucleus is directly volume of the nucleus only we can tell as size of the nucleus, or the radius of the nucleus we can tell as size, and volume of the nucleus is more means size is more. Size is measured in terms of volume. Volume of the nucleus is directly proportional to the mass number, proportional to the mass number, right? That means we write here volume is directly proportional to mass number. We write A. B proportional to A we write. What is the volume of the nucleus? Volume we write is 4 by 3 pi r cube. 4 by 3 pi r cube. Volume is directly proportional to mass number. Mass number means what? Number of nucleons. If more nucleons are there, more volume will be there for the nucleus. Less nucleons are there means less volume will be there. Simple it is. Then the volume is proportional to mass number. Then volume of the nucleus formula is what? If the nucleus has r radius. If nucleus has capital R radius. If nucleus has capital R radius, then what is it the formula for its volume? Nucleus has capital R radius, then its volume, we can write as 4 by 3 pi r cube we write. Okay, right. Now we write in that formula V proportional to A formula we have to write. We know this volume proportional to A formula, right? And here we know V proportional to A. V proportional to A. What we write? V is the 4 by 3 pi r cube, right? 4 by 3 pi r cube proportional to A we write. And 4 by 3 pi is a constant. Why we are writing the volume of the nucleus as 4 by 3 pi r cube? We are taking R as a radius. Nucleus is just like a sphere. Sphere radius is R. A sphere volume is 4 by 3 pi r cube. That's all we can write. But 4 by 3 pi is a constant. We write R cube proportional to A. We write r proportional to what we write. We do one thing, whole power 1 by 3 on both sides. R cube power 1 by 3 proportional to A power 1 by 3. Then from this we will get R proportional to A power 1 by 3. Then this is the most important formula. When the proportional R proportional to A power 1 by 3. Okay, right. And this we can write, if the proportionality is removed, we will get a constant. That is R is equal to R naught into A power 1 by 3. R is equal to R naught into A power 1 by 3. The important fact. What is R here? R is the radius of nucleus. Radius of nucleus. What is R naught here? R naught is the proportionality constant. Here when we remove proportionality, we got this one. That's why it is said to be proportionality constant. Okay. And R naught has some value, fixed value. It is the 1.2 Fermi. Fermi means we can write that as 1.2 into 10 to the power of minus 15 meters we can write. Okay, right. Next, A is the mass number. Mass number means what? Number of protons plus number of neutrons. Okay, this is we can write as Z plus N. Z plus N. R naught value you should remember. This is the formula for the radius of the nucleus. We can measure the size by using radius. You must remember. Okay, right. Let us go for the next topic. We got the radius of the nucleus formula and we will solve one problem based on this. Okay, and I want the answer from you for that question, and that is a previous CBSE question. It is very important for the exam. Okay, I think you will solve within 1 minute and you will send me, because it is very easy. Okay, till now is it clear now, students? The question is that I will see the question. Compare the radii. Previous question, previous CBSE question. Whatever the problems that I am explaining, that are very very important. Most repeated CBSE problems I am explaining. But in the last lecture, I saw that till now I made the 30 minutes lecture. Most important problems in the ray optics. But till now only 2 members watched. It is showing the 70 minutes watch time. 70 minutes watch time. Only 2 members watched. Then why you are doing like this? Don't do like this. Be alert and do the work properly. Okay. Right. Compare the radii. Compare the radii of nuclei. Compare the radii of nuclei. They gave the two nuclei. Oh, that is 13 aluminium. What is the mass number? 27. And one more they gave is Te. Te means what? Do you know? Can you write in the chat box? 50 to 125. Okay, they are asking to compare the radii of these two nuclei. It's a previous CBSE question. Okay, it is a CBSE previous question. Okay, right. Now write the answer for you, all of you. Try to write the answer. I'm expecting. I will wait for 1 minute. Okay, and you write the chat box. You write in the chat box. Puneet, Aditi, expecting answer fastly. Compare the radii of nuclei. You know formula for the radius of the nucleus? Just now size of the nucleus is nothing but radius of nucleus only. Size of the nucleus is nothing but radius of nucleus. Okay? No. No one giving. I am not getting any answer. Radius of nucleus formula is what? Just now we derived. R is equal to R naught into A power 1 by 3. This is the formula. From this, the radius is proportional to A power 1 by 3. And then we want A1 is equal to what they give? First nuclei mass number is 27. First nuclei radii we can consider as R1. Second nuclei mass number 125. Mass number means what? This is the mass number. Telenium. You see here 125, 27. And second nuclei radius we can take as R2. Very easy problem. We write in the ratio form this equation. R1 by R2 is equal to A1 by A2 whole power 1 by 3 we have to write. A1 is what? Can you tell? 27. A2 is what? 125. Whole power 1 by 3. This we write like this. 27 we write as 3 cube. And 125 we write as 5 cube. Whole power 1 by 3 we write. And then we will get like this answer. R1 by R2 is equal. This we write as 3 by 5 whole power 3 into 1 by 3. Is it right? Then answer is 3 by 5. Right? Have you got anyone? Students? Not giving the reply. Okay, let us go for the next continuation. That is the next topic is the yes, Aditi gave the answer. At 118 I got the answer. 3 is to 5. Good. Right, let us go for what about the other members? Why you are not replying? I am waiting for your reply. I am seeing my mobile only for the chat box. Okay, I am expecting the answer fastly. And this is the next topic is the density of the nucleus. How we can find out the density of nucleus? Density of nucleus, how we can find out? Okay, there is a one question is there based on this density of nucleus. They may ask the question like this: show that the density of nucleus, density of nuclei is independent of mass number. We have to show that the density is independent of mass number that we have to show. or we can say that they can ask the question, this question in another way also, that they will ask like this: density of the nucleus we have to find out, and they are asking the question that density of the nucleus is independent of mass number. It will not depends upon the mass number, that we have to show. It does not depends upon the mass number means different elements have different mass numbers. Okay, and all the elements have the same density. That means that we have to prove. Okay, let us start. How we can find out the density of the nucleus? Consider an element. Consider an element of mass number. Element of mass number. Consider an element of mass number A and atomic number. Consider an element with not mass number, element with mass number. Consider an element has capital A number of. Consider an element has capital A number of nucleons. Okay, actually, number of nucleons means what? Mass number only. Mass number only called as number of nucleons. You know very well, na? Okay. Consider an element has capital A number of nucleons. Okay, and each nucleon has mass. We can consider as consider an element has A number of nucleons. Each nucleon mass is small m. Nucleons means what? Protons and neutrons. The protons and neutrons have the almost same mass, that we are taking as small m. Okay, protons and neutrons have the same mass, nearly 1.66 into 1.67 to the power of minus 27 kg. Okay, almost they have the same mass, and one proton or neutron mass is small m, and nucleus have the A protons. Then how we can find out the density of the nucleus? Density of nucleus formula is what? Density of nucleus formula is mass of nucleus by volume of nucleus. Right? This is the formula for that. And this is a nucleus. This is considered as one nucleus. This nucleus radius is considered as R, and this nucleus has A number of nucleons. Okay, right. This density I want to find out, density of the nucleus. How we can find out the density of the nucleus? Okay, it is the volume of the denominator. It is not appearing. Na? And density of the nucleus we write is density of nucleus we write as here, just like this. Density is the rho, and mass of the nucleus. Mass of the nucleus means mass of the nucleus means mass of constituent particles. Actually, in the nucleus, protons and neutrons are there, nucleons are there. One nucleon mass is small m. In the nucleus, A nucleons are there. And mass of nucleus is nothing but mass of nucleons. Mass of nucleons. Mass of nucleons is what? One nucleon mass is m. A nucleons are there. That's why am we will get. Volume of the nucleus. What is the volume of the nucleus? Volume we write is 4 by 3 pi r cube. Right? Radius of the nucleus is capital R, means volume of the nucleus is 4 by 3 pi r cube. Are you understanding this one? This is the mass of the nucleus. This is small m is the mass of one nucleon. A is the number of nucleons. One nucleon mass is small m. A nucleon's mass is am. A is the total number of nucleons. This is the total mass of nucleons is nothing but mass of nucleus. The volume of the nucleus is 4 by 3 pi r cube. Then we can continue now. because we know r equal to r naught a power 1 by 3, that we have to write, and we can continue. Then I'm going to take this one to left side, and you take the screenshot and note it, right? Next step, what I am going to write. In the next step, we are writing, but we know radius of the nucleus as r is equal to r naught into a power 1 by 3. This we write in above equation. If you write that one, what you will get? Rho is equal to, we will get as am by 4 by 3 pi into r is r naught a power 1 by 3 whole cube we write. Here we know r is r naught a power 1 by 3. Next step, we have to simplify it. This 3 goes to the numerator. Rho we write as am by 4 by 3 pi into this r naught cube we will get. R naught cube a power 1 by 3 whole power 3. A power 1 by 3 whole power 3. 1 by 3 into 3. 1. A you will get. Okay. This A and A will be cancelled. This 3 will be goes to the numerator. We will get 3m by 4 pi r naught cube. Right? From this formula, we say that the density of the nucleus is independent of mass number. This is the formula to find out the density of certain nuclei. Okay, whatever it may be the nuclei, hydrogen or helium or lithium, beryllium, boron, carbon, nitrogen, whatever it may be, right? And then for all the nucleons, this is the formula for the density of the nucleus. And from above equation, what we can write? From above equation, we write like this. From above equation, we write. Sir, class ले रहे हैं sir. Class. From above equation, we can write one thing. From above equation, density of the nucleus density of nucleus is independent of density of nucleus is independent of mass number. Okay, independent of mass number we write, and or otherwise we can also write like this, right? And all the nucleons have the same density. Density is the same for all the nuclei. Why? It does not depend upon atomic number, it does not depend upon mass number. That's why density of all nuclei is same. Density is the same for all nuclei, right? Every nucleus have the same density, right? Understand? Okay. Now let us find out the density. All the nuclei have the same density means what is the value of the density? Just we have to find out. Okay, and it was very simple to find out. Then how? Now m is what? Mass of nucleon. Mass of nucleon is nothing but mass of proton or the neutron. Its value is 1.67 into 10 to the power of minus 27 kg. Okay, and r naught is the constant. What is the value of r naught? Proportionality constant 1.2 Fermi. Fermi means 10 power minus 15 meters. You substitute these values in above equation. Then we will get rho is equal to 3m by 4 pi r naught cube. Okay, substitute values. That is rho is equal to 3 into m is what? M is the 1.67 into the power of minus 27 by 4 pi value is 3.14. R naught is the 1.2 into 10 to the power of minus 15 whole cube. Now you simplify it. You will get 2.3 into 10 to the power of 17 kg per meter cube. This is the density of any nucleon. Okay, right. Let us go for the next topic. The next topic is the very important in the board exam, right? And you listen very carefully. Today, I gave some introduction. In that, the most important I am going to start now, and you listen very carefully. Right. What is the most important? The most important is that mass defect. Mass defect and binding energy, and we will discuss the two topics and we will close today. Mass defect and binding energy. It will not take much time. Don't worry. What is our topic? Mass defect first. Mass defect. Okay. Next one is the binding energy. What is mass defect? What is mass defect? Mass defect is nothing but, for example, we know that nucleus, how the nucleus is made. The nucleus is made up of protons and neutrons. Protons, neutrons, protons, neutrons, like this. Nucleus is made up of protons and neutrons. But here, the nucleus mass should be equal to, mass of nucleus should be equal to what? Mass of nucleus must be equal to mass of constituent particles. What are the constituent particles? What are the nucleons? Mass of nucleus must be equal to mass of nucleons, because nucleus is made up of nucleons, but that is not equal in the practical. The mass of, they find that mass of nucleus less than the mass of nucleons. Actually, what happens? Three. How lithium atom will forms? For example, uh, 3 lithium 6 is there. Okay, for example, lithium nucleus is formed with the 3 protons. This is a 3 and the 3 neutrons, right? Lithium nucleus is formed with the 3 protons and 3 neutrons. 3 protons mass and 3 neutrons mass, if you will add 3 neutrons mass, if you will add, what you should get? You should get the lithium nucleus mass. Mass of protons plus mass of neutrons should be equal to mass of nucleus. But in the practical, right, and the mass of nucleus is less than the mass of nucleons. That means, just simply in the normal language I will tell. For example, just assumption. Okay, just assumption. Okay, and 10, there are 10, what happened? We have the 10 protons. Okay, 10 protons and 10 neutrons. By combinedly, one helium nucleus is formed. For example, helium nucleus formed. Helium atomic number 10. Helium nucleus formed. Then 10 protons mass. For example, 10. One proton mass is 1u, 1 AMU. If 10 protons mass 10u plus this one is again 10u, and helium nucleus mass should be equal to 20u. But in the practical, right, and if you see the, we are getting the 20u we are getting. This is the mass of proton and mass of neutrons. If you add the mass of proton and neutron, this is the mass of proton and mass of neutrons. If you will add, you are getting this one, 20u. But mass of nucleus, how much we are getting? Some 19.5 u we are getting. This is the mass of nucleus. Actually, this nucleus mass should be equal to 20u, but we are finally we are finding the 19.5u. I will explain once again. Helium nucleus is formed by the 10 protons and 10 neutrons. 10 protons mass is 10u, 10 units, and 10 neutrons mass is 10 units. Then total mass of nucleons is 20u. Now the nucleus is made up of these 20u mass, but after making the nucleus, we find the nucleus mass is 19.5u. That means during the formation of the nucleus, there is some energy is released, right? Why energy released? Here some mass is destroyed. Okay, 20u nucleons combinedly forms the nucleus, but after forming the nucleus, we are you are losing the, you're getting less mass. That means some mass is lost at here. How much mass loss occurred at here? That is called as a mass defect. Okay, why this mass defect is occurred? Okay, how much mass lost at here? That loss of mass appears in the form of energy. That energy used to bind the nucleons in the nucleus. Have you understood? Is it clear, students? This is the most important point at here. What is the mass defect? Have you understood? Have you understood, students? Write in the chat box. Write in the chat box. Okay, I'm going to erase this. What happening? After working the 1 hour, your our mind is will not work now. Then similarly, this our my pen tab also not works after continuous work for the 1 hour. Okay, right. We are discussing the mass defect. Slowly it will works. After listening the 1 hour lecture, your mood also off. Similarly, this board is also not working after doing the work for the 1 hour. Nowadays, you are not responding fastly, you are not sending the notes. Is there any reason for that? Right, what is the mass defect? I'm waiting for the response, but it is not giving the response. There is some lagging is there. Are you observing the condition of this one board? Right, what is going on here? Right, now it is click on the red pen. Right, now I think it will work. Now we are discussing the mass defect. What is mass defect? Okay, what is mass defect? Mass defect is nothing but Mass defect. I explained the mass defect right till now. I will give the definition now. Mass defect, how you will get? It is the difference in the mass of nucleons to the actual mass of nucleus. The difference between the difference between the difference between mass of all nucleons mass of all nucleons in a nucleus to the actual mass of nucleus. The actual mass of nucleus is called as mass defect. This is the mass defect. Okay, mass defect is what? Mass defect is the mass of nucleons minus mass of nucleus. Mass of nucleons minus mass of nucleus. Very important topic. Don't leave the class and you will face the problem in the future. And mass defect is the mass of nucleons minus mass of nucleus. This can be denoted with delta m. Okay, delta m. What is the mass of nucleons? Okay, for example, if you take any element, how many protons it has? For example, we will do one thing like this. Mass defect we will take as delta m, and mass of nucleons is nothing but mass of protons plus mass of neutrons. What is the mass of protons in an element? For example, this is an element, it has z protons, then one proton mass we take mp, z protons mass is the zmp. Okay, one nuclear element has z protons, one proton mass is mp, z protons mass is zmp. Nucleons means neutrons also comes. How many neutrons are present in the element? A minus z. How one neutron mass you take m suffix n. Total number of neutrons is a minus z. Then a minus z into n. It is the mass of all neutrons minus mass of nucleus we want. Mass of nucleus is nothing but minus capital M. This is the formula for the mass defect. The mass defect formula is ZMP plus A minus Z into Mn minus capital M. This is the formula, right? Have you got what is this? In this, mass of nucleons is there and mass of nucleus also there, right? Now let us see. We will discuss some more points at here. That is, what are the terms which are present in this? We have to go for the terms, right? What are the terms which are present in this? First one, MP. MP is what? Mass of one proton. Okay, mass of each proton. All the protons have the same mass. Mass of each proton. And what is Z? Z is the number of protons. Number of protons is nothing but atomic number, right? No? It's an atomic number. Atomic number. And what is M suffix N? It is the mass of each neutron. Mass of each neutron. And A is what? A is the mass number. A is the mass number. You know what is mass number? Number of protons plus number of neutrons. A minus Z is what here? Number of neutrons. Number of neutrons. And one more is missing. What is capital M? Capital M is the actual mass of nucleus, right? Actual mass of nucleus. And this mass defect can be measured in AMUs. Remember it. Mass defect is measured in AMUs. And this mass defect, some mass is lost during the formation of actual uh, nucleus. Okay, right. I explained it also clearly what is mass defect. Okay, and you note the some values of proton and electron. Okay. For that I will take this one to left side and I will write the values of mass of proton and electron. Okay, first mass of proton is what? One proton, how much mass it has in AMUs? You note it. Okay, mass of proton is m suffix p. Its value is 1.00727 AMUs. If you want to write in the kgs, we will get as 1.6726 into 10 to the power of minus 27 kg. Okay, and the next I want the mass of neutron. Mass of neutron. What is the mass of neutron? The mass of neutron is m suffix n. Its value is 1.00864 u AMUs. In AMUs this one, and in kgs 1.6750 into 10 to the power of minus 27 kg. And the next mass of electron. More 10 minutes I will continue. Okay, students. Mass of electron. What is mass of electron? It is 9 point, oh sorry, in AMUs I want to give 0 0.00000055 u. In kgs 9.1 into 10 to the power of minus 27 kg. In kgs you have to write this many zeros, after that one will comes. That's why we are measuring in the AMUs. Okay, okay students, now listen very carefully. I'm going to continue, and the next topic is the binding energy, right? I will take this also left side. Right, more 10 minutes, more 10 or 5 minutes only I will close, don't worry. Right, I will explain the binding energy and I will close. Next one is the binding energy. What is the binding energy? Okay, binding energy. Binding energy. Okay, binding. It is also actually some energy you require to bind the nucleons in the nucleus. That energy is the binding energy. In the name only it is there. Right? Binding energy. Binding energy is the E suffix B we can write. Its definition is the how much mass destroyed there. Generally, for example, you are burning the one wood. You are burning the wood of 1 kg. After burning, you will get the energy, heat energy, and light energy. And after that, you will get ash. That ash mass is not equal to mass of the wood that you are burning. That means there is some loss of mass is there out in the burning. Similarly, during formation of nucleus also, protons and neutrons are combinedly forming the nucleus. During that formation of the nucleus, there is some loss of mass. That loss of mass convert into energy. That energy used to bind the nucleons in the nucleus. Protons and neutrons are bind in the nucleus. That is called as the binding energy, right? The binding energy is nothing but how much mass defect is occurred, equivalent to that energy is called as the binding energy. The energy equivalent to the mass defect, the energy equivalent to the energy equivalent to the mass defect. Okay, some mass defect is there, that mass defect convert into energy. That's why energy equivalent to the mass defect is called as binding energy. This is one definition. And there is one more definition is also there. You can note it. That is the energy required required to split the nucleus into nucleus into its constituent particles. Constituent particles. Nucleus, some energy required to split the nucleus into particles, nucleons. For example, we want to split the nucleus into nucleons. For that, how much energy required? The energy required to split the nucleus into its constituent particles. Constituent particles are what? We are splitting the nucleus into nucleons. That's all. The energy required to split the nucleus into nucleons, its constituent particles, is called as binding energy. That is called as binding energy. Understood? Okay. What is the formula for the binding energy? I will give the formula for the binding energy and I will close. Right? And then the binding energy is equal to binding energy, we write binding energy. Relation between the binding energy and mass defect we can write. Okay, the relation between binding energy and mass defect. Okay, right. That is what happened. Mass defect. That is the binding energy is equal to binding energy is equal to this we can write as E suffix B binding energy, that is equal to mass defect into C square. Mass defect into C square. This we can write. Okay. What is delta M in this? Delta M is the mass defect. Mass defect. C is the speed of light. Speed of light. Okay. And mass defect formula is also, you know, right now. Binding energy formula we can also write like this. Mass defect is what? ZMP plus A minus Z into Mn minus capital M into C square we have to write. This is the mass defect into C square. Next, we write here delta M. Delta M is the mass defect. Delta M mass defect is this is the mass defect into C square we can write here. Okay. And the next C is the speed of light. Here we got one condition we have to take, that is the delta M is the delta M. If the delta M is in the kgs, if delta M is in the kgs, if delta M is in if delta M is in kgs, okay, and then and C is the we write here like and C we write as 3 into 10 to the power of 8 meter per second. In SI system you substitute. When you substitute them, then you will get the energy. Energy you will get in joules. Binding energy you will get in joules. Binding energy you will get in joules. Okay, and that means in this formula you will get in the joules, but you should substitute the delta M in kgs. C is the speed of light. Binding energy you will get in the joules when you substitute delta M C in SI system kg and speed of light. For example, if you substitute in delta M in AMUs, then what happens? Okay, delta M if you substitute in AMUs. One question I will ask you: how much energy releases if delta M mass defect? Thank you, Ashish. If delta M is the mass defect, okay, delta M is the mass defect. We are taking if delta M is the mass defect, if it is in AMUs, delta M is the mass defect. If it is in AMs, then AMU, that means atomic mass unit. Mass defect is also measured in AMUs. Then how we can find out the binding energy? If delta M measured in AMUs, then binding energy we write like this. Binding energy EB is equal, we can write as, okay, delta M into 931.5 mega electron volts you will get. This is the binding energy formula when delta M is in AMUs. If delta M AMUs, then only we have to use this unit, this formula. Why? How you are getting this formula? Previously I gave the formula as students. I am going to close actually more time. From last 1.5 hours onwards I am continuing. I think you are boring. uh, Sorry for the extension today. And one question I will ask you, that the energy equivalent to what, last one, energy equivalent to 1 AMU mass. The energy equivalent to, the energy equivalent to 1 AMU mass is, okay, the energy equivalent to 1 AMU mass is 931.5 mega electron volts. For example, if you destroy 1 AMU mass, how much energy releases? That is 931.5 mega electron volts. If you destroy anything, if you burn anything, then energy releases. You are destroying this much mass, then this much energy releases. Then you can also find the energy released by using a formula, that is the binding energy E equal delta mc square. Okay, you write here delta M as 1 AMU. Okay, delta M we write as 1 AMU, that you convert into kgs while using this formula. Okay, that is kg is 1.66 into 10 to the power of minus 27 kg. Okay, and C value is 3 into 10 to the power of 8. You substitute these all values in above equation, you will get the binding energy. You will get the binding energy as delta M is what, 1.66 into 10 to the power of minus 27 kg. 27 into c square we write here, 3 into the power of 8 whole square. You can simplify it. When you simplify it, you will get some value, that is 931. You will, when you simplify this, you will get in the joules, na? Because we are substituting all in kgs and meter per second, you will get in joules. In order to convert this joules into electron volts, you should divide with electron charge. 1.66 into the power of minus 27. This we write as 9 into the power of 16. You know, if you divide this with 1.6 into the power of minus 19, you will get in electron volts, because 1 joule is equal to 1 by 1.6 into 10 to the power of minus 19 electron volts. Okay, to convert joules to electron volts, we have to divide this like this, and you will get like this. This value you will get is 931.5 into 10 to the power of 6 electron volts you will get, and this you will get as 931.5. this 10 power 6 we write as mega electron volts. That means if you destroy 1 AMU mass, how much energy releasing? 931.5. 1 AMU mass is equivalent to how much energy? Equivalent to 931.5 mega electron volts energy. 1 AMU mass is equivalent to the 931.5 mega electron volts energy. Okay, right. 1 AMU mass is equal to this much. 1 AMU mass energy equal to 931.5. For example, delta M AMU mass destroyed means how much energy releases? Delta M into 931.5. Okay, one chocolate cost this much. Delta M chocolates cost how much? We write with, we multiply with delta M, that's all. Is it right? Then we will get as delta M into 931.5 mega electron volts. This formula we will use when you have the delta M in AMUs. Understood, students? Okay, thank you to all. And I took the, I think, nearly 1.5 hours. If you have the doubts, and we can continue in the next class. Thanks a lot. And we have the two formulas for the binding energy. One is delta m into 931.5. While using this formula, delta m must be in AMUs, and another formula delta m c square. While using this formula, delta m must be in kgs. In this, delta m must be in kgs. Okay, that's all. You will get EV in the joules. This is the most important point that you have to remember. Okay, thank you to all, and I will try in the next time. I will add Hindi also. Okay, I'm going to close. Thanks a lot to all for waiting till now. Okay, right. Bye to all.